In part 1, we built this rocket, the Phantom Blue. Like we said in the last video though, the real fun comes from launching the rocket. In order to launch the rocket though, we need to figure out which engine to use. Fortunately, the manufacturer does recommend certain engines. In the case of the Phantom Blue, we have the A83, the B64, and the C65. It's always best to make sure that the first flight is with the lowest power engine. In this case, it's the A83, because you don't know how it will fly. And by using the lowest power engine, even if it flies erratically, by using a lower powered engine, it's still easy to recover. The engine is designated with a letter and 2 numbers, but what do they mean? The letter gives you the maximum impulse of the engine. Impulse is measured in Newton seconds. It is the force that the engine produces measured in newtons. This is the engine thrust, multiplied by the time that the force is applied in seconds. In order to make your rocket go higher, you can apply more force to it, more newtons, or you can apply that force for a longer period of time, more seconds. For an A engine, the maximum impulse is 2.5 newton seconds. For a B engine, the maximum impulse is 5 newton seconds. And for a C engine, the maximum impulse is 10 newton seconds. Now, you'll notice that each letter upgrade is twice the power of the one before it. After the letter is a number which gives the average thrust of the engine in newtons. Now, you might be wondering, does the A8 engine actually produce more thrust than the B or C6 engines? And the answer is yes, it does. But because the B and C, the B6 and the C6 engines have more fuel, they'll burn for a longer time, which results in a higher total impulse, and as a result, your rocket flying higher. And you can actually see this when you look inside the engine. If you look inside the A engine, then the fuel only covers about 1/3 of it. If you look inside the B, it's about half. And looking at the C, it's pretty much filled all the way to capacity. After the fuel in the rocket engine is exhausted, the rocket is no longer is accelerating, but it continues to coast upward. There's a delay before the parachute or the streamer is deployed. During this time, a smoke trail is released, and this helps you to find the rocket in flight. As you can imagine, the rocket by this time is moving very fast, and it's very small. So finding it when it's hundreds or possibly even 1,000 feet in the air can be pretty difficult at times. Following the smoke trail really helps. And the last number in the model rocket engine designation is the time in seconds of the coasting phase when the smoke trail is being released. At the end of the coasting phase, the rocket has reached the highest altitude of its flight, or apogee, and there is an ejection charge released in the direction of the nose cone, which deploys the parachute or streamer. This will bring your rocket slowly and safely back to the ground so that you can launch it again. It's best not to launch your rocket when it's really windy, but it's kind of hard to find days when there isn't any wind. So make sure that you check the wind direction before you launch and follow the smoke trail. You'll be sure to recover your rocket when it returns to Earth. In the next episode, we're going to take the Phantom Blue out on location and launch it using these engines. We'll show you how to have a safe and successful launch. We'll see you next time.